new topic for today's class. Okay, what do you think? What may be the meaning of this transpose of matrix? Do you have any idea? Transpose means what may be its meaning? Okay, if we consider a matrix, this is a matrix A, B, C, D, E, F. What is the order of this matrix? Can you state its order? What is its order?
2 by 2.
2 by 2? Is it 2 by
3
2?
by 2.
Okay, it has 2 rows and it has 2 columns, 3 columns, 2 rows and 3 columns. Now, this can be altered, or the rows and columns can be interchanged to form the another matrix. That means if it is transposed as if it is transformed as like AD, means this column has made or has been transformed to form column. Sorry, this column has been transformed to form row. Similarly, BECF. Now, this matrix has been transformed to this matrix just by interchanging the row into column and vice versa. Means the row has become column and column has become row. The elements A and D, formerly it was in column, now it has come to form a row. BE it was column and here it is row. CF it was in column and it is now in row. So this type of transformation of the matrix by interchanging the rows and columns. Interchanging the rows and columns means the rows will be column and column will be row, and this is called as transpose of matrix. This is called as transpose of matrix. Transpose means it is the matrix which is formed by interchanging the rows and column of a matrix. That is called as transpose of matrix. Okay, transpose means the matrix which is obtained by interchanging the rows and columns is called transpose of matrix. It is called transpose. Transpose means just to transform a matrix by transforming the matrix by interchanging the rows and column is transpose. Now, if we assume A as a matrix, let A be a matrix, then its transpose can be denoted either by A to the power capital T or A to the power small t or simply A prime. So all these 3 symbols, 3 notations can be used to denote the transpose of a matrix. Okay. Have you understood this?
Yes, sir.
Let A equals to 1, 2, 3, 4. It is a matrix of order 2 by 2. Now, A transpose means A to the power T can be written as, what can we write for this? This row should be transformed to column. This row should be made column now. Now, A1, 2 and then second column forms, so second row forms second column, 3, 4 like this. The first row forms first column, second row forms second column. So in this way, a matrix can be transformed just by interchanging the rows and columns. It is called as transpose of matrix. It is called as transpose of matrix. Okay, now let's do some examples. In the examples of transpose also, it will compose or it will contain addition, subtraction, multiplication by using a scalar. All these things will be contained in this portion also, in this section also. Transpose means it is just property of the matrix, so that is why it will be included in all those operations also. Now the question says A equals 3, 5, 6 and 7. Matrix B is 1, 0, 2 and 4. Now find the first one is A transpose. Second one is B transpose. The third one is A transpose plus B transpose. Fourth one is A plus B whole transpose. Okay, it is asked. I think you can do it easily. Okay, tell the answer of that first. A transpose, what can be the elements of a transpose?
3, 6, 5, 7.
3, 6, 5, 7. Okay, 3, 6 formerly it was in column, now it will form rows. And B transpose?
1024.
1024 means 10 will be in column, right? Okay, do 1, 2, 3, 4. Do these questions and get the answer. Matrix A is 2, 3, 6, 7. Matrix B is 2, 1, 5, 6. We need to find A transpose, B transpose, A transpose minus B transpose, A minus B whole transpose. So in the previous question, we had added the transpose of the matrices. Here we need to subtract. The process is same, only the operation is different.
Yeah, I got.
Same answer.
Yeah, same answer.
Okay, here transpose is 2, 6, 3, 7. We just interchange this row and column, and B will interchange this row and column. 2, 1 is row here, it will be column. 5, 6 is row, it will be column here. And A transpose minus B transpose, 2 minus 2 is 0. Similarly, 6 minus 5 is 1, 3 minus 1 is 2, 7 minus 6 is 1. Okay, this one. And similarly here in this case, we need to subtract this at first. A difference B or A minus B, then we need to take transpose of that answer. Now 3 number is if A equals 4, 5, 6, 7, verify that A transpose whole transpose equals A. We need to find this. We need to verify this. The matrix A is given as 4, 5, 6, 7. Now the transpose of A transpose is A. That we need to prove. So for this, we need to take LHS. LHS is A transpose whole transpose. A transpose whole transpose. So let's find out the transpose of A at first. It is 4, 5, 6, 7. Now we can write 4, 6, 5, 7. This is A transpose. Now this transpose can be copied as it is. This 4, 6, 5, 7 is the transpose of A. That means it is the value of A power T. Now again power T is there, so that is why power T. Now we need to transpose this matrix again. Now we'll get 4, 5, 6, 7. 4, 5, 6, 7. 4, 5, 6, 7. Now is this A? Is this A? Let's check here. 4, 5, 6, 7. In row there is 4, 5. 4, 5. In second row there is 6, 7. There is 6, 7. That means this can be written as A also. It means A power T whole to the power T is A. It is right hand side. Proved or verified. So it can be verified in this way. It is the property of transpose as well. It is the property of transpose also. Whenever we take the transpose of transpose, then the original matrix will be formed. A transpose whole to the power T means whole transpose equals matrix A. The transpose of the transpose is equal to original matrix. Next question is for you. If A equals 2, 6, 3, 7, 4, 9, prove that A transpose whole transpose equals A. Same question. Same question. Matrix A equals to 6, 3, 7, 4, 9. The order is 3 by 2. There are 3 rows and 2 columns. Now we'll make a matrix which has 2 rows and 3 columns now. Because rows and columns will get interchanged. The rows and columns get interchanged. So the new formed matrix will be of 2 by 3 order. In the case of a transpose, again that should be transposed and the original matrix should be formed. Arivan proved?
Yes.
Okay. Very simple questions, right? Very, very easy. Finished?
Yes, sir.
Okay. If so, then this operation part is finished. Now, in the operation of the matrices, we have learned in operations what did we learn in this portion? We learned about addition. So, how can we check the compatibility of for addition? At what condition we can say the two matrices are compatible for addition? Can you state the condition? Can you state condition? When the order of two matrices are equal, then the matrices are said to be compatible for addition and the corresponding elements are added. This is addition. Second one is subtraction. The same condition in case of subtraction also. Addition and subtraction has same condition. When the order of the two matrices are same or equal, then only the two matrices are said to be compatible for subtraction also. Next one is multiplication. Multiplication by using a scalar. We have not learned the multiplication of matrices yet. We just have learned about the multiplication by using a scalar. And whenever a scalar multiplies the matrix, all the elements, all the members of the matrix get multiplied by that scalar. We discussed up to this, and similarly we have discussed up to the transpose also. Transpose means it is just to interchange the rows and column of the given matrix. The interchanged form of rows and columns of the matrix is called its transpose. Okay, so these are the various operations. Now we'll move on into the next topic then. The next topic is properties of matrix addition. Properties of addition of matrix. Properties of matrix addition. Let's discuss on the property. The first property is called as closure property. closure property. Now, closure property states that, so it is like the condition of the matrix multiplication also, sorry, matrix addition also. In order to be compatible for addition, the two matrices must have same order. Now, after the addition, the result will be also of same order. The result will also be of same order, and it is called as closure property. It is called as closure property. Like if A and B are of same order, then A plus B will have same order as well. Same order as well. If the two matrices A and B will not have the same order, then the two matrices cannot be added. And if they are compatible for addition, then the result will also have the same order. Like for example, if A is 1, 2, 3, 4, it is of 2 by 2, and B is 2, 3, 4, 5, it is also of 2 by 2. Now these two matrices can be added. Then we can find A plus B. In A plus B, the corresponding elements will get added. Like 1 adds with 2, 1 plus 2, 2 adds with 3, 2 plus 3, 3 adds with 4, 3 plus 4, 4 adds with 5, 4 plus 5, which is equal to 3, 5, 7, 9. Now we have got the result. We have got the sum of these two matrices, and the order of this sum is also 2 by 2. So the order of this first matrix 2 by 2, second order is 2 by 2, the order of the matrix or resultant matrix is also 2 by 2. So in this way, if these two matrices are compatible for addition, then the resultant matrix will also have the same order that the component matrices possess. So this is called as closure property. It is called as closure property. Closure property means in like if in simple language, what we can say is 2 is natural number, right? Natural number. We are discussed in real number chapter also. 2 is a natural number. Natural number means all the counting numbers that starts from 1, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to infinity. These all are natural numbers. Now if we say 2 a natural number, 3 is also a natural number. Now if we add these two, we'll get 5. 5 is also a natural number. 5 is also a natural number. So what is that component? The resultant should be also that same thing. If this satisfies, then that satisfies the closure property. So in this case also, in the case of addition of matrices also, the order of the matrix will be will have one order, means the two matrices will have one order to be compatible for the addition, and if they are added, then the sum will also have that same order. Like here, A is of 2 by 2, B is of 2 by 2 again. Now they are added, the resultant matrix or the sum will also have that same order. It is called as the closure property. Is this clear now? Or do you have any question?
Yes, sir.
Okay, so then let's move to next property. It is commutative property. Commutative property. Commutative property means if A and B be two matrices, if these are two matrices, then A plus B equals B plus A. It is called as commutative property. Commutative property means if A plus B is calculated, then we'll get one sum, and that will be equal to B plus A as well. That means A plus B equals B plus A is called as commutative property. Like for example, For example, if A equals 1, 2, 3, 4, B equals 5, 6, 7, 8. Now we can find A plus B. A plus B equals 1 plus 5, 2 plus 6, 3 plus 7, 4 plus 8. Now this is equal to 1 plus 5 is 6, 2 plus 6 is 8, 3 plus 7 is 10, and 4 plus 8 is 12. We got this. Similarly, let's find out B plus A also. Now B plus A will be equal to B plus A. Firstly, we'll write the elements of B. 5 plus 1. 5 plus 1, and then 6 plus 2, and 7 plus 3, 8 plus 4. Now we'll get 5 plus 1 is 6, 6 plus 2 is 8, 7 plus 3 is 10, 8 plus 4 is 12. So we got this. Now look at this. These two matrices are equal. So if these two matrices are equal, then the commutative property is satisfied. The commutative property is verified. Have you understood this commutative property?
Yes, sir.
A plus B equals B plus A is commutative property. A plus B equals B plus A is commutative property. That is commutative property. Now, next, okay, I'll give one question to you. The question is, if P equals 1, 2, 3, 4 and R equals 2, 1, minus 2 and minus 3, prove that, or let's say verify that P plus R equals R plus P. Okay, get the answer of this. P plus R equals R plus P.
Done, sir.
Okay, is it verified?
Yes, sir.
Have you got same answer on this both?
Yes, sir.
Okay, the answer will be how much? 1 plus 2 is 3.
3, 3, 1, 1.
2 plus 1 is 3. 3 minus 2 is 1.
3, 1, 1.
1. Okay, this one in right hand side also same, right? 2 plus 1 is 3. 1 plus 2 is again 3. Minus 2. Minus 2 plus 3. 1. Minus 3 plus 4 again 1. Okay. So in left hand side and right hand side both are same. So it is verified. Now let's move on to next property. Third property. The third property is associative property. Associative property. So associative property means if A, B and C are three matrices of same order, if these matrices A, B and C are of same order, then we can say A plus B plus C equals A plus B plus C. It is called as associative. Now the meaning of this bracket is we need to solve this a plus b at first, and c will be added with that result, with that sum. And here b plus c is kept inside the bracket. It means we need to solve b plus c at first, and the sum will get added with this a. Now the result of this and this will be equal. It means the answer will be same. The answer will be same. Like for example, a equals 1 2 3 4, b equals 2 3 5 6, and c equals 7 8 9 5. Okay, these are the three matrices. Now if we find LHS, left hand side, here is a plus b plus c, a plus b plus c. A plus b is kept inside the bracket, so that is why we should solve a plus b at first, right? Now can you say how much will be a plus b? A plus b will be how much? Till row wise?
3, 5, 8, 10.
3 5 8 and 10, plus c 7 8 9 5. Now how much will be our answer? I guess we tell this.
10,
10,
13,
yes. 8 plus 9,
14,
and then last.
15.
Okay, so this is left hand side, LHS. Now let's find RHS as well. RHS. So what does this RHS say? A plus, now inside the bracket there is b plus c. Inside the bracket there is b plus c. A plus b plus c inside the bracket. Now, so A, let's copy it as it is. A is 1 2 3 4. Now let's add b and c. B and c, how much it will be? Anusri, b plus c.
9,
Okay, it is 9.
10,
2 plus it is 10. Sorry, 3 plus
sorry,
8. 11.
11,
5 plus 9.
14,
Right. Next,
11,
11. Okay, now let's add it. Let's add it. How much will be our sum?
10,
10.
13,
3 plus.
17,
Okay.
and 15.
15. Okay. Are these two values equal?
Yes, sir.
Yes. It means left hand side is equal to right hand side. LHS equals RHS verified. So in this way, this type of properties can be verified. Okay, we have discussed three types of property of the addition today. Now I'll give some questions to you as your homework. Question number one is if you can copy these questions, P equals 2 3 4 5, Q equals 2 4 4 1, then verify a number is P plus Q equals Q plus P, B number is P plus Q prime equals P prime plus Q prime. Prime means transpose, eh? This prime means transpose. And similarly, C is 2P prime plus 2Q prime equals to 2 times P plus P prime plus Q prime. Okay, this one. Number 2 is let A equals 1, 2, 3, 4, B equals 2, 4, 6, 7, and C equals 2, -2, -3, 1. Verify that A plus B plus inside bracket equals A plus B inside bracket plus C. Okay, these two questions.